My name is Stanley Adussis, and in this lesson, we will understand how and why developers often skip design mode and go straight to text mode when building their XML layouts. In design mode, we simplify layout construction by turning it into a hand cramping, drag and drop affair, but we can move faster and with more precision in text mode. To create a new layout file in text mode, we open the Resource Manager, click the plus icon in the corner, and choose Android Resource File. XML can represent more than mere layouts. This resource generating pop up window helps guide us in creating the exact type of file we want. In this case, we want a layout file, one which will ultimately represent a contact card displayed by our main activity. To follow Android's layout file naming convention, we provide the arrangement we expect to find within the file, a contact card, and append the class name of the object responsible for displaying the arrangement, main. The default type of resource is values, and a values XML file stores design data such as dimensions, text, and styles. But several options exist. For this occasion, we want to create a layout file. Below, we find even more options, the resource qualifiers. Resource qualifiers allow us to create alternate versions of a resource tailored to one or more device factors, screen size, aspect ratio, Android version, and others, such as screen orientation. For example, we may create two versions of our card layout file, one designed for screens in landscape mode and a default version designed for portrait mode. We're going to use the one-size-fits-all approach for now, one layout file for all possible configurations. The root element initializes the very first XML element in the file, and for layout files, Android Studio defaults to the linear layout. And if we erase that on accident, we can get it back by typing linear. What's this? Two linear layouts? That's right, narrator from a second ago. Two linear layouts, one with no package prefix and one slapped on the end of something called Android X. Two versions of linear layout exist because one is part of the standard Android development kit and the other comes bundled with Android X, a support library designed to bring new features to old devices. Here's why. Imagine the earliest Android device attended a dinner party for up-and-coming smartphones. On the menu that night, dessert. The first phone was practically stuffed after filling up on Android 1.5, codenamed Cupcake. Unfortunately, also on the menu that night, way more dessert. Suddenly, desserts are flying out of the kitchen faster than this slab of semiconductors can keep up with. Meanwhile, modern guests arrive and find the old phone in the middle of an embarrassing party foul. Android X to the rescue. By taking the best and smallest bits from the new versions of Android, Android X enables older devices to have a taste of new APIs and Android technology as they arrive piping hot out of the oven. While relying on Android X is not a requirement, in some occasions, we have no other choice. Constraint layout is not a part of any version of Android, past or present, and is only available through Android X. Whereas linear layout was available in version 1 of the Android development kit, and its backwards compatible version is also available through Android X. Here's a contrived example which shows why we might choose the Android X version over the one available on the user's device. In Google's documentation of linear layout, we can learn about its methods and properties. One in particular is named getAccessibilityClassName. In the top left, Google provides a drop-down toggle displaying our targeted Android version, version 29. When we created our project, we set its minimum API version to 15, which Google introduced in 2011, 14 versions ago. Why did we pick version 15 when 29 had all the sweet little goodies? Over 99% of all Android devices run at or above version 15, which means the majority of Android devices would run our application without any issues. However, a lot can change after 14 major software releases, and this toggle helps us discover precisely those changes. Android introduced the getAccessibilityClassName method in version 23, 8 releases after our minimum API requirement of 15. If we called this method in our application on a device running Android version 22 or lower, it would fail to find a method by that name and go out with a bang, which in our case means crash the app. So if we absolutely positively needed this benign method and our application's minimum API version was below 22, we would use the version of linear layout found in Android X, the version which provides new linear layout features to old versions of Android. Segue over. Back to the action. As we can see, when searching for constraint layout, the only option available is found within the Android X library. We close the resource manager to focus and switch to text mode to provoke us. into learning. We are so sorry for that line. So far, it's not much to look at. The resource manager did the exact job we expected. It created a layout file and shoved a constraint layout inside. To better understand these files, we will focus on them line by line. This line is found atop every XML resource file in our Android project. We can ignore it like our distant cousin at the family reunion. Present, non-threatening, but oh so boring to engage. A left angle quote always begins an XML object and is followed by the name or absolute class path which the object represents. This attribute defines an XML namespace for the file, and namespaces help prevent attribute conflicts. For example, the default layout width and layout height properties both belong to the Android namespace, but other namespaces exist. Case in point, we begin typing the word tools and a convenient suggestion appears. The tools namespace refers to attributes only accessible by Android Studio, attributes applied exclusively during development. When defined, namespace definitions remain gray until we use the namespace somewhere in the document. Gray is fine for now. Gray happens to match everything anyway. And we must not overlook another critical namespace, app. App refers to any attribute defined by something other than the Android development kit, meaning any custom attribute we define ourselves or attributes defined within our libraries, for example, Android X. Earlier, an angle quote began this XML object, and now an angle quote must close it. In the case of view groups, we must provide a separate closing XML object to identify the end of the view group. And the view group's children are everything in between these two XML objects. To add a new element in text mode, we need only type. A single left angle quote is all it takes, and Android Studio handles the rest. All standard and not so standard layout components appear in this list, including those found within Android X. To bring a contact's face to our contact item, we will use an image view, the view responsible for presenting, surprise, images to the user. Android Studio does us a quick favor by immediately inserting both layout width and layout height into the image view's attributes, both of which are mandatory. For width, we set 0 density independent pixels. This permits constraint layout to stretch image view to fill the full width of its horizontal constraints. By pressing the tab key, we can jump to the next required value, layout height, for which we choose a static dimension of 200 dp. Much like in design mode, text mode attempts to warn the developer if the layout file contains any obvious flaws. In this case, we've provided neither vertical nor horizontal constraints for this image view. To correct this, we create a new line and begin to type layout constraint. As we can see, Android X defines layout constraint and all attributes related to constraint layout, so we must use the app namespace to provide those attributes. Thankfully, even when using attributes defined by external libraries, Android Studio offers meaningful suggestions with autocomplete. For our purposes, the contact card's image must align with the left, top, and right edge of its parent. We have the mandatory constraints set, but without a placeholder image, we have no way to judge the quality of our layout. Enter Tools. An image view's src attribute defines the source of the image, and by using the tool's namespace, we ensure that only Android Studio reads this attribute, and never the user's device. Furthermore, we can access sample images provided by Android Studio by typing the @ symbol and selecting sample/avatars. Okay, but the image does not fill the width of the image view, which spans the full width of its parent container. We have to use another image view attribute to change that behavior, scale type. By setting the scale type as center crop, we instruct the image view to stretch the source image until it fills both the width and height of the image view's bounding box. Much better. One error lingers. Image view is not a view group, and therefore cannot contain views within it, so we must close its representative XML object with the /. And to once again show off the capabilities of constraint layout, we must add a second view. We create a text view to display the contact's name. For its appearance, we apply the headline style found in our theme. And during design, we will use the text attribute in the tools namespace to define some placeholder content. The horizontal constraints remain identical to the contact's photo, binding the text view to the left and right edges of its parent. But we want to place the contact's name below their photo, and to do that, we'll need a resource identifier. For views to relate or constrain themselves to their siblings, they need a way to reference them. Resource identifiers satisfy this need. Back in our image view, we add an identifier to it using the ID attribute. Android Studio suggests we write app+id/, the prefix to any new resource identifier. Following that, we define a name for this resource, IV as an abbreviation of image view, avatar to define its purpose, and contact card to identify the layout in which it appears. Unfortunately, identifiers map one to one with their names, which is why we must take care to create unique names for each identifier we assign in a single layout. Otherwise, we risk presenting layouts with multiple views that answer to the same ID. With our ID prepared, we hit Control or Command on Mac plus Spacebar to reveal what Android Studio has already discovered, a sibling view with an identifier. Selecting the image view's ID presents the expected result, the contact's name placed right beneath their picture. But to keep them from hugging a bit too tightly, we apply 16 dp margins to our text view. With the help of Android Studio and a series of well-suggested autocompletes, building a layout in pure XML text becomes a viable option for all developers.